Welcome to CSE Guru. In this session, we will discuss how to solve a knapsack problem using memory function method. This is the second method of solving knapsack problem in dynamic programming technique. And here, the inputs if we are considering in the sense, everything is similar to previous method only. N is nothing but number of objects. M is nothing but the maximum capacity of the knapsack. W is nothing but array consisting of the weights of each object. And P represents the profits of each object. And V is nothing but the two-dimensional array size n plus 1 rows and m plus 1 columns, and where we will achieve the maximum solution. That is represented by V. And the formula if you are considering in this is that is also everything similar to previous method only. If the weight of the corresponding object is greater than the remaining capacity in the sense, we have to apply f of I minus 1 comma j. Suppose if the weight of the object is less than or equal to the remaining capacity j in the sense, we have to apply this formula, that is maximum of f of I minus 1 comma j comma f of I minus 1 comma j minus wi plus pi. Okay. So these two formula only we are going to use. So now we will discuss with one problem. The problem is apply the memory function method to solve the following instance of the knapsack problem with the maximum capacity m is nothing but 5. And they have given 4 items with its corresponding weights and profits. So here if you are considering in the sense, the given values are n is 4, m is 5 and w1 is 2, w2 is 1, w3 is 3 and w4 is 2. So these are all the weights of the corresponding objects. And the profit of the first object is 12, profit of second object is 10, third object 20, fourth object 15. And if you are considering here, this is the initial adjacency matrix to compute the profit. Initially, we know if the set V of I comma j, if either I value is 0 or j value is 0 in the sense, profit is 0. So that one only we know initially. Okay. And here in memory function method, if you are considering in the sense, this is a bottom up approach. Okay. Previous method is a top down approach. Solution starts with the initial step and we will find the profit in each level. Okay. That is for the first object, second object completely, third object, fourth object likewise. We will compute the profit. And where we will obtain the optimal solution, that is nothing but the maximum profit. But in memory function method, if you are considering in the sense, it is a bottom-up approach. This bottom-up approach starts with the last level. That is the last leg. So last leg, if you are considering in the sense, 4, 5. If you are considering, this is the last leg. So we will start with V of 4, 5. And we will proceed towards the top. And here, we are not going to find all the levels of profits. Okay, wherever it is required, only those we are going to compute in bottom-up approach. And we will start to fill the profit from the bottom and proceed towards the top. Okay, so this memory function method is a bottom-up approach. So here, the step 1, if we are considering in the sense, first we will start with the last level. So the last set if we are considering in the sense, V of 4, 5 is the last step. So here, I value is 4 and j value is 5. Okay. So weight is nothing but 2 and profit of the fourth object is nothing but 15. And here if we are considering in this sense, the weight of the object, that is the fourth object weight is less than j. Okay. So weight is 2 and the remaining capacity is 5. So wi is less than j. So if wi is less than or equal to j in the sense, we have to apply this formula. That is maximum of V of I minus 1 comma j comma V of I minus 1 comma j minus wi plus pi. Okay. So this is the formula we are going to apply here. So V of 4 5 equal to maximum of V of I minus 1. So V of 4 minus 1 in the sense V of 3 5. V of I minus 1 comma j comma V of I minus 1, that is 4 minus 1 3 comma j minus wi. So j value here is 5 but wi is 2. So 5 minus 2 in this sense, this is also 3. Plus profit of the fourth object is 15. So here, which one is maximum? How we will find? We need to find v of 3 comma 5. Again, we need to find v of 3 comma 3. Then only we can able to come to the conclusion which one is maximum. Okay. So since we don't know v of 3 comma 5 and v of 3 comma 3, next step we will find v of 3 comma 5 and next we will find v of 3 comma 3. So step 2, we need to compute v of 3 comma 5. So here I value is 3 and j value is 5. And the weight of the third object is 3, profit of the third object is 20. So W3 is 3 and profit of the third object is 20. And here, so W3 less than J. The same formula we have to apply. So V of 3 comma 5 equal to maximum of V of I minus 1 comma J. I is 3, 3 minus 1, 2, comma J is 5, comma V of I minus 1, comma J minus WI. That is 5 minus 3. So 5 minus 3 in the sense 2. Plus profit of the third object is 20. Okay. And here if you are considering in the sense, here also we don't know the value. V of 2 comma 5 we don't know. V of 2 comma 2 also we don't know. Okay. In order, we need to find all the sets. So first we need to find out V of 3 comma 5. So we have computed here. Next V of 3 comma 3, next V of 2 comma 5, next V of 2 comma 2. Likewise, in order we need to find. So step 3, this we need to compute. V of 3 comma 3. So V of 3 comma 3. So here I value is 3 and J value is also 3. And weight of the third object is 3 and profit of the third object is 20. And here W3, if you are considering in the sense, W3 is equal to J. Okay. So W3 is 3 and J is also 3. So if it is less than or equal to in the sense, we have to apply the same formula. So we need to find V of 3 comma 3 equal to maximum of V of I minus 1. I is 3, 3 minus 1 is 2, J is 3, comma V of I minus 1, 2, comma J minus WI. 3 minus 3, the value is 0. Okay. Plus profit of the third object, if we are considering in essence, it is 20. Okay. So with this, we are going to compute V of 3, comma 5 and 3, comma 3. Next, we need to compute 2, comma 5 and 2, comma 2. So fourth, we need to compute V of 2, comma 5. So here I value is 2 and J value is 5. Okay. And the weight of the second object, if you are considering in this sense, weight is 1, profit is 10. So here if you are considering in this sense, W2 less than J. So same formula. So V of 2, comma 5 equal to maximum of V of I minus 1, 2 minus 1, 1, comma J is 5, comma V of I minus 1, 1, comma J minus WI. 5 minus 1 is 4. Plus profit of the fourth object is 10. So here also we don't know the value. We have to compute these sets. Okay. Fifth step. In order, what is the next set we need to find? It is V of 2, comma 2. So V of 2, comma 2 we need to find. Here I value is 2 and J value is also 2. And the weight of the second object is 1. Profit of the second object is 10. So W2 is less than J. 1 less than 2. So same formula. V of 2, comma 2 is equal to maximum of V of I minus 1. I is 2. 2 minus 1, 1, comma J is also 2. Comma V of I minus 1, comma J minus WI. J is 2, 2 minus 1. It is 1. Plus profit is 10. Okay. So in order, we need to compute these two sets also. Okay. So now this set we have computed with these two steps. And this we have computed with these two steps. Next, from the third step, what is the next set we need to find? It is V of 2, comma 3. V of 2, comma 3 and V of 2, comma 0. So sixth step, here I value is 2 and J value is 3. And the weight of the second object, same second object, weight is 1 and profit of the second object is 10. So here if we are considering 1 less than 3. So W2 less than J. Okay, so we need to compute V of 2, comma 3. So the same formula, maximum of V of I minus 1, I is 2. So V of 1, comma J is 3, comma V of I minus 1, 2 minus 1, 1, comma J minus WI, 3 minus 1 is 2, plus profit of the second object is 10. So next we need to compute these two sets also. And next, seventh step, if we are considering, from the third step, we need to compute V of 2, comma 0. And here, I value is 2, J value is 0. And the weight of the second object, if we are considering in the sense, it is 1. And profit of the second object, if we are considering in the sense, it is 10. And here, if we are considering in the sense, here J value is 0. If either I value is 0 or J value is 0, in the sense, what is the value we will get it? It is 0. So, V of 2, comma 0, 0. So, this is the only solution initially we know. If I value is 0 or J value is 0, in the sense, automatically profit is 0. Okay, so that we are applying here. Now, third step is also over. Okay, next come to fourth step, we need to compute 1, comma 5 and 1, comma 4. So step 8, we need to compute V of 1, comma 5. Next V of 1, comma 4 we need to compute. Okay, this is step number 9. So here I value is 1 and J value is 5. Weight of the first object is 2, profit is 12. So here if you are considering weight is less than J. So here W1 is less than J. Okay. So if it is lesser in this is the same formula. That is V of 1, comma 5 equal to maximum of V of I minus 1. 1 minus 1 it is 0. Comma J value is 5. Comma V of I minus 1. I is 0. Comma J minus WI. 5 minus 2 is 3. Plus profit of the first object is 12. Okay. And here, if you are considering in the sense V of 0, comma 5, automatically it will be 0. Since I value is 0. 0, comma 3 also it will be 0. Next, V of 1, comma 4, if you are considering in the sense, here I value is 1 and J value is 4. And weight of the first object, if you are considering in the sense, its value is 2 and profit of the first object is 12. And here if you are considering in the sense 2 is less than 4. That is W1 less than J only. The same formula we need to apply. So V of 1, comma 4 equal to maximum of V of I minus 1. 1 minus 1 it is 0, comma J value is 4, comma V of I minus 1 is 0, comma J minus WI. If you are considering in the sense 4 minus 2, it is 2. Plus profit of the first object is 12. Okay. Next, we are considering here, we have computed 1, comma 5 and 1, comma 4. This is also over. And next we need to compute 1, comma 2 and 1, comma 1. So this is step 10. We need to compute V of 1, comma 2. And next 11th step, we need to compute V of 1, comma 1. So here in 10th step, I value is 1, J value is 2 and weight of the first object is 2 and profit of the first object is 12. Okay. And here weight is equal to J. If it is equal also the same formula. Okay. So V of 1, comma 2 is equal to maximum of V of I minus 1. 1 minus 1 it is 0, comma J value is 2, comma V of I minus 1 it is 0, comma J minus WI. 2 minus 2 it is also 0. Value is 0. Plus profit of the first object is 12. Okay. Next we need to compute V of 1, comma 1. So here I value is 1, J value is 1 and weight of the first object is 2 and profit of the first object is 12. So here if you are considering in the sense weight 2 is greater than 1. So V of 1, comma 1 equal to weight is greater than 1. We have to apply the formula V of I minus 1 comma j. So V of I minus 1. I is 1. 1 minus 1 is 0. 0 comma j value is 1. So here since I value is 0, automatically the value we will get 0. Okay. Next step 12. So here if you are considering in the sense we have computed 1 comma 2, 1 comma 1 also. Next we need to compute 1 comma 3 and 1 comma 2. 1 comma 2 already we have computed in step 10. So we need to compute 1 comma 3. So step 12, we need to compute V of 1 comma 3. So here I value is 1, J value is 3 and weight of the first object is nothing but 2. Profit of the first object is 12. Here if you are considering in the sense weight is less than J. So 2 less than 3. So if it is lesser in the sense, we have to apply the formula, this one. V of 1 comma 3 equal to maximum of V of I minus 1. I is 1, 1 minus 1 it is 0, comma J value is 3, comma V of I minus 1. 1 minus 1 value is 0, comma J minus W. 3 minus 2 value is 1. Plus profit of the first object is 12. And here, whatever the new set we got, for everything we have computed. Okay. And next step, we need to apply the values for each set what we have computed. And here, if you are considering in the sense, since V of 0, comma 3, the value is 0. And here the value is 0. And here the value is 0 plus 12. Which one is maximum? Value we will get it as 12. Okay. In the previous step, if you are considering, it is V of 0, comma 1. Okay. So the value is 0 only. Now we need to substitute the value backward. Okay. Next, step 10, if you are considering in the sense, V of 0, comma 2, value is 0. 0, comma 0 also value is 0. 0 plus 12 in the sense, here also we will get value 12. Okay. Previous step, V of 0, comma 4, value is 0. V of 0, comma 2, value is 0 plus 12. So here we will get value 12 only. In previous step, similarly, 0, comma 5, value is 0. 0, comma 3 also 0 plus 12. Maximum value is 12. And V of 2, comma 0, value is 0. So here if we are considering V of 1, comma 3. V of 1, comma 3, what is the value? It is 12, comma V of 1, comma 2. V of 1, comma 2, value is 12. Plus profit of this object is 10. So what is the maximum value we will get here? It is 22. 12 or 22, we will get 22. Next, we need to move backward. That is V of 2, comma 2, we need to find. So V of 2, comma 2, if you are considering in the sense, it is maximum of V of 1, comma 2, what is the value? It is 12, comma V of 1, comma 1. Value is 0 plus 10. Which one is maximum? 12 is maximum. So V of 2, comma 2, value is 12. Next, move backward. We need to find V of 2, comma 5. So V of 2, comma 5, if you are considering in the sense, it is maximum of V of 1, comma 5, value is 12, comma V of 1, comma 4, value is 12. Plus profit of this object is 10. So here also we will get value 22. Next, we need to apply for V of 3, comma 3. So here it is maximum of V of 2, comma 3. What is the value? 22. Comma 2, comma 0. Value is obviously 0 since J value is 0. Plus 20. Profit is 20. Which one is maximum? 22 is maximum. So V of 3, comma 3 also value is 22. Next, move upward. We need to apply for V of 3, comma 5. So this is maximum of V of 2, comma 5. 2, comma 5. What is the value? It is 22, comma 2, comma 2. What is the value? 2, comma 2. Value is 12. Plus profit of this object here is 20. Okay. Which one is maximum? 32 is maximum. Okay. Next, move upward. So here we will get maximum of V of 3, comma 5. What is the value? It is 32, comma 3, comma 3. What is the value? It is 22. Plus profit of this object is 15. So which one is maximum? 32 or 37? 37 is maximum. So this is the optimal solution. Okay. So here in memory function method, if we are considering in the sense, we have start the solution from the last level. Okay. That is V of 4, 5. So start with V of 4, 5. And what is the set we need to compute? We will get it here. Okay. In order, try to compute these sets. We have 3, 5 and 3, 3. Again, in this set also, we need to compute 2, 5, 2, 2, 2, 3, 2, 0. Likewise, in order, we need to compute. Whichever the new set we need to find, we have to continue the steps like this. Okay. So, wherever we are getting the solution, we have to save the solution and we have to use it to apply backward. So, whenever we are not getting any new sets to find, okay, then whatever the values we have got for the previous sets, try to apply backward, okay, and find the solution. We will get the profit. If you are applying backward, finally at step 1, if you are applying in the sense, we will get the maximum solution, and that is nothing but the optimal solution. And these profits, we need to fill it in the profit table. And here, if you are considering the profit table, the first row and first column values already we know. Since I value or j value is 0 in the sense, we have to apply 0 here. Okay. Next, we have computed V of 4, 5, the value is 37. V of 3, 5, value is 32. And V of 3, 3, value is 22. Okay. Next, if you are considering in the sense, V of 2, 5, the value is 22. And 2, 2, value is 12. Next, if we are considering in the sense, V of 2, 3, value is 22. And V of 1, 1, value is 0. Okay, similarly, we have computed for 1, 2, 1, 3. V of 1, 2, 12, 1, 3 also 12. Next, we have computed 1, 4, 1, 5. So, there also value we have computed 12 only. And here we are considering in the sense these sets. It is not necessary to find the solution in memory function method. But in the previous method, what we have done, there is a top-down approach. We have started from the initial solution and we have tried to find for each object. We have considered each object and we have tried to find the profit for each set. That is 1, 1, 1, 2, 1, 3, 1, 4, 1, 5. Next, we have considered the second object and we have computed the profit for each set at second row. Next, we have considered the third object and we have computed the set 3, 1, 3, 2, 3, 5 up to 3, 5. And this continuous procedure we have applied. So, there we need to find the profit for each set. But in memory function method, it is not necessary. Whichever it is a required set, only for that set we have computed the profit. And we have obtained the optimal solution. And the optimal solution here is 37. The same result we got in the previous method also. Okay. So, this is the procedure to implement knapsack problem using memory function method. And this memory function method is a bottom-up approach. And the previous tabulation method is nothing but the top-down approach. So, these are all the two methods in dynamic programming technique to solve the knapsack problem. Thank you for watching this video.